Hello, hello. Purpose of today's video is to not talk about how to calculate slope, but rather, now that we know how to calculate slope, what does it mean and how could it be represented? So I want to make sure that everybody understands that when we're finding slope, it's just basically a constant rate of change, and since slope is a rate, we should understand how to work with rates in a variety of different shapes and sizes, if you will. So what we're going to do is I'm going to give you a line, a graph of a line, and I'll give you the slope of the line. Then what you are going to need to do is, for one, invent a context so that instead of thinking about x's and y's, we're thinking about something meaningful or even something not meaningful, but something concrete to visualize. Then what we're going to do is we're going to take that slope 1/3 and we're going to express it in 4 different ways, and then we're going to show how those 4 different ways can be represented graphically. So the idea here is I'm going to tell you the slope is 1/3, but I'm going to tell you the slope is 1/3 in 4 different ways. All would mean the same thing, and then show you how in the graph we end up with the same general truth. So for starters, the first thing I need to do is what's called a unit slope. What I mean by unit slope is we're always going to set the change in x to be 1. So that is to say, if I take any point on the graph and go over 1, how much up do I go? And so to figure this out, what we're going to do is, we're going to get the right slide up. What we're going to do is we're basically going to take this 1/3 and make it equal to 1/3 to 1. There's a 1/3 to 1 ratio. So essentially what I'm doing here is I'm dividing by 3 on the top and dividing by 3 on the bottom. But you don't have to show divide by 3 on top and bottom, because really the fact that this is 1/3 is equal to 1/3 over 1 should be pretty self-evident at this point. So anyway, what that means is my unit slope will be defined as 1/3, because my context, y dollars over x days, says that every 1 day I make 1/3 of a dollar. So it's a 1/3 to 1 ratio, which means every 1 day, so I go over 1, I make 1/3 of a dollar that way. So if you want to see this in more detail, you can see that I went to my graph and I picked any point on the graph. Now I chose this point as a place to start just because it was a nice point on the x-axis. It doesn't matter where I start though. I should go over 1 centimeter, and then I should show that it goes up about 1/3 of a centimeter. So that's somewhere between 3 ticks and 4 ticks, so that's about 0.33. So my graph now labeled shows every day I make 1/3 of a dollar. Every day I make 1/3 of a dollar. Oops, I lost something here. What I meant to say was, every day I make 1/3 of a dollar. My graph says every 1 day I go up 1/3 of a dollar more. The next slope that I need to do is the change in y over change in x slope, and that one is the most straightforward. That says the change in y is 1 and the change in x is 3. Then every 3 days I make $1. Using a ruler, I take it to my graph and I measure out from any point, and this time I just chose this random point right here, and I said over a 3-day span, so I went over 3 days, I will make $1 more, so I went up 1 centimeter. So you can even see that the ruler, when matched up to the graph, is approximately 3 centimeters wide. So the point of the graph is to show that going over 3 up 1 gives you the same rate of steepness as going over 1 up 1/3. Scaled up slope. Now this is where you get to make your choices. Basically all you have to do for a scaled up slope is multiply top and bottom by a big number to get a ratio that is still true, only much grander scale. So if I make 1/3 of a dollar every day, then I'm going to make $300 every 900 days. So that's my scaled up slope. Now I had to create a new graph to show this because I needed to have a scale that's different than my 1 centimeter scale over here. So I just showed 900 days, $300. So that's the scale up. Now you don't have to use 300. You can use billions or whatever you want. The point is 900 to 300 to 900 is the same ratio as 1/3 is to 1, as 1 is to 3, and so on and so on. Finally, for a fraction slope, all I have to do is multiply top and bottom by a number that is a fractional number. Now, I used a half because I can do that stuff in my head, but you can use any fractions you want. I can make 2 3/4, multiply top and bottom by 2 3/4, and you're going to get, here you'll get 2 3/4 on the top, and on the bottom you will get 8 1/4. So 2 3/4 to 8 1/4 is going to be a 1-to-3 ratio as well. But anyway, the fraction ratio is to show you that even clean ratios like 1/3 can be expressed in a variety of different ways. So this statement that I made down here is really profound. It says a 1.5 to 4.5 is the same as 300 to 900, which is the same as a 1-to-3 ratio, which is the same as 1/3 to 1 ratio. So all 4 of these bullets are saying something that looks or appears to be different, but is describing the same ratio every time. And again, we can see that on the graph itself as 3 different ratios, all giving us or generating the same level of steepness because the rates are the same. So that's what you're going to have to do. In each case, you invent a context, and then you express your unit slope, your change in y over change in x slope, scale up to whatever you want it to be and show that on a separate graph, and then the fraction slope, you just basically multiply top and bottom by whatever you want to get an equivalent fraction that's ugly, basically, and all of them will mean the same thing. So your task would be to do all 6 of these. And by the time you're done, I hope that you're going to become really good at working between the different varieties of numbers as slopes. We can work with slopes in a variety of different ways, and rates in a variety of different ways, and that's your goal here, is to understand how rates can be used interchangeably in a variety of different contexts. So, hope you find that helpful. Have a good day.